Hi, physics. Here's our lesson for today. We have talked about different types of energy. You guys analyzed that Roadrunner cartoon, and now we're moving on to work. So we did energy, the three different types: radiant, kinetic, potential. We broke down the radiant, we broke down the different types of kinetic, and we broke down the different types of potential. So we're moving on to work. We'll probably do a little bit of kinetic energy with it. All right. Kinetic energy is abbreviated KE. Okay. So today's date is the 27th. Now, for work, work is producing a change in the environment. That sounds really similar. It's also kind of the same definition for energy. So it's producing a change in the environment. I can never spell environment. Okay. So for work to occur, a couple of things have to happen. I don't know if you did your actively learn from yesterday. So what I need you to do is I need you to stand up, pause the video, and go push on a wall. All right, so go do that. Go push on a wall. Do it for like 30 seconds. Push as hard as you can. Try and move the wall. All right. Did you move the wall? Hopefully all of you at least tried it. So usually I have you guys demonstrate this in class. I would say, hey, Shane, come here and push this wall. All right. And so Shane would be pushing the wall. And maybe I would say, okay, Tam, come here. I'm going to ask you to do bicep curls with a pencil. All right. Who's doing more work? Is it Shane who is, if it's a hot day, trying to push the wall, might be sweating a little bit? Or is it Tam trying to do some bicep curls with a pencil? All right. Who's doing work? It is Tam. Why is Tam doing work? Tam is doing work because she has produced a change in the environment, a change in the pencil. She has made the pencil move. And unless Shane suddenly acquires like incredible Hulk strength and can push a wall, if there's no motion, work has not been done. So in order for work to happen, you must have motion. So maybe I called up two other people, right? And I said, Aiden, come on up. And I need you to hold a stack of 10 physics books. All right, so Aiden's standing in the front of the room holding 10 physics books. All right, and I might say, hey, Cass, can you write your name on the whiteboard with a marker? Who's doing work? Cass. Cass is doing work because the marker is moving. Aiden, no matter how heavy those books are, if they're motionless, if he's just standing there, no work has happened. But maybe I said, hey, Aiden, can you carry those books to the book room? Now Aiden is doing work because the books are moving. So work is totally dependent on motion. The equation for work is force applied over a distance. We can break that down. The easiest way to remember this is what is force? F equals mg A. So all I did is I took force and I substituted MA, and I'm going to tack on D. All right, so think about this. Work makes you mad. Okay, work makes you mad. And this equation is really simple. You just multiply everything together, and there you go. That's it. So with that, let's say maybe Ada, maybe you're not carrying those books down to the book room. Maybe you're carrying them to, I don't know, we're going to store them all in Miss Lucart's room. So maybe the mass of 10 physics books, maybe it's, let's see here, I don't know, maybe it's 60 pounds. So we'll call that 30 kilograms. And Aiden, maybe you're walking down the hall at a rate of, it'd be really funny if you walked 2 meters per second. That's really fast. Maybe you walked 0.5 meters per second squared. And the distance from my room to Miss Lucart's room, maybe it's 35 meters. Okay. So, and I want to know, how much work did Aiden do carrying the books? All right. So what you're going to do is you're just going to multiply mass times acceleration times distance. All right. So you can take your handy dandy calculator. Maybe you have one out. Maybe you just have a cell phone calculator handy. So 30 times 0.5 times 35 is 525. All right. Well, what's the label for work? Work is really energy. So energy is measured in joules. Work is measured in joules. So work is energy. Energy is work. We need motion to occur. It was just a bunch of multiplication, and you tack on the label for joules. Okay. Let's go back to the pencil. All right. Maybe we want to calculate the kinetic energy that's being generated by doing a bicep curl with a pencil. Kinetic energy is 1/2 mv squared, 1/2 times mass times velocity squared. All right. So maybe with this pencil analogy of doing bicep curls, the mass of the pencil is really tiny. Let's see here. It's probably 0.04 kilograms. All right. And maybe the bicep curl, so you're moving it from, arms being straight to, bending them. Maybe you generated a velocity of 15 meters per second because they're so light. When we calculate kinetic energy, all you do is just plug in 1/2 mass times velocity squared. Okay, so go ahead and plug that in. We've got, let's see here. I got 4.5. It's a small number. It's a small number because pencils are very light. 4.5 what? Joules. Okay. That is our lesson for today. Make sure to copy and post this in your notes. Okay. Oh, someone's hijacking my screen. Tom, you want to say hi? What did you draw? All right. Tom just said he drew a thing for my schoolwork. All right. So have a good day. Copy these down. These are really simple.